Okay, the units that we are in Unit 6, and it is called Chemical Nomenclature. So, nomenclature, you should have maybe heard that word back in biology. I'm not going to say that you have, but nomenclature is the process of naming something. This slide is not on the PowerPoint. Sorry.
Okay. Do you want to write it?
I mean, as long as you know what the definition is. So nomenclature is a process of naming things. The scientific name for human is what? Homo sapiens. Okay? It's the same for America as it would be in Europe or whatever. We have to have a universal naming system. And because we need that universal naming system, we have to have rules when it comes to naming stuff so that everybody is on the same page. Okay? So, chemical nomenclature is a system of naming compounds. That's it. We have 4 or 5 different names, or 4 or 5 different types of compounds, and there's going to be rules for each type of compound. So you're going to have to be able to look at a compound, identify what's going on in that compound, and then coming up with the rules that we come up with today, you're going to take those rules and you're going to practice naming. I'm going to guide you through the rules so that you don't come up with some willy-nilly rules and it's all wrong. Any questions on nomenclature, what we're doing for the next 2 weeks? All right. So here I have why bother. So how would you speak, Ivan? Al2SO4, close parentheses, 3. How would you say that? How? Tyler might come up with a name.
Yeah, come on, Tyler.
And then Will might come up with something else. So we all have to be on the same page of how we're going to name it. So we have this system, and it's called IUPAC. IUPAC. International Union of Pure and Applied Science. I do not expect you to memorize what IUPAC means, but I expect you, when you see IUPAC on the test or a quiz, and it says, give me the IUPAC name for this compound, you know I'm asking you for the system that we use. Okay? So it's just a system. Because inevitably you'll go, what's IUPAC when you're reading the test? Any questions?
You have to know, like,
No, I don't expect you to know the acronym. Okay. So the next thing, what we're going to do today, and we're doing part 1. You have a group of pink cards at your desk. They represent binary compounds. Binary means what? 2. So binary compounds means that it is going to be a compound made of 2 elements. Every card is a compound made of 2 elements in that package. On one side, you'll see that there is the name. On the other side is the formula. Okay? So one's the name, one's the formula. You're going to use these to figure out the next slide. So my overall goal for today is to come up with rules on how to name binary compounds. So what you need to do is look, where you're going to have periodic tables. You have the periodic table there. You're going to look at the periodic table. You're going to look at your cards. You're going to identify the 2 types of compounds. When I say identify the type, I mean metal or non-metal.
these are periodic tables.
You can use your colored. In fact, I would have your colored periodic table out. Yes. So first of all, so your first thing, let me go through the directions. First thing is identify the type. And then once you've identified the two types of metals, you should be able to tell me what type of bond it is. Your next step, which type of element is listed first? Number 3, is there anything unusual about the name of the first element? Anything unusual? When I say unusual, I'm saying when you're looking at the name of that first element on your pink card and look at the periodic table, is it different, or is there anything unusual about it? And then number 4, is there anything unusual about the second element? And then if there is, then you need to tell me what it is. So those are the 4 things you're searching for. I'm giving you about 5 minutes to search for that stuff, come up with those answers, and then we're going to come back and do our rules. Are there any questions? So like, I don't need you going and identifying, oh, this is lithium and this is what, and this is fluorine and this is whatever, and do each one of them. They're all together as a group. What is each type of element? The first one. What is each type of element? The second one. Okay? All right, I'm going to give you about 5 minutes to work on that, and then we will come back. Okay, so let's answer these questions, and then we're going to come back and put our rules. What I expect in your notes is you writing these rules down. So first of all, what are the 2 types of elements? Somebody tell me, what are the 2 types of elements that we have in our binary compounds? Metal and non-metal. Which means what type of bond is it?
Ionic.
It is an ionic bond. Which element is listed, type of element is listed first? The metal. Is there anything unusual in its name? Not all of them. Most of them end in IUN. But is there anything different from the periodic table from what's on your card? No. For just the first, for the metal. No. The name is the same. Now for the second one, what has happened to the second one's name?
You put I at it.
The name is changed. Name ending. Well, let's just put it this way. Ends in IDE. We're going to use these answers right here to help us come up with our rules for naming binary compounds. Any questions on those? So next, looking at somebody, Tyler, give me a formula for one of the compounds that you have.
SrCl2.
SrCl2. Okay. And then we have NaCl. So why are the elements combined in different ratios? Why do I need 2 chlorines for every 1 strontium, whereas I need 1 chlorine for every 1 sodium? Because of the electrons, okay? What happens to the electrons in an ionic bond? They're not perfectly shared. They are. What happens in an ionic bond? What do? We transfer the electrons. When we transfer the electrons, what happens to our neutral atom? It now becomes a what? A positive or a negative, which means it now becomes an ion. So we transfer the electrons and we get ions. When these ions hook up, their overall charge has to equal 0. has to equal 0. So what does that mean? That means if I go back to doing dot diagrams, NaCl, what happens? The Na transfers its electron to the Cl. And is it happy? It is happy.
It's got all those electrons.
So they're both happy. So then it becomes NaCl. Right? What happens in strontium? Strontium has how many valence electrons? I hear 2. So strontium has 2 valence electrons. How many does chlorine have? 7. So we transfer the electrons. Chlorine is happy, but strontium is not. So we need another what? Another chlorine.
That's 7, so I can fill in the last one.
So remember we drew these diagrams last year or in last semester, and we wrote those formulas. Remember we did write these formulas, and that's what we're going to be doing now. Okay? All right, so 3 rules. So what is the very first thing you need to do when you are naming these types of compounds? Put the metal first. But before we can do that, what do we need to know about the compound? We need to know that we need to identify that it is a ionic binary. Binary ionic bond. If it does not fall under that, then our rules are going to be different. That's rule number 1.
So is there one right after the one?
Huh?
The one after the one?
What? That's an ID. Identify. So your very first thing, look and see. Is it it's binary? If it's binary, is it ionic? Once you've done that and that satisfies, you've said check, yes, that's right. The next thing we need to do is what, William? What are we going to do? Name the what? Name the metal first. Do we change its name? No. So the name stays the same. The second thing, or the third, thank you. Once we've named the metal, what do we do now? We name the nonmetal. Changing the ending to IDE. Huh? That's fine. So what I would put in your notes, I would put that this is binary compound naming, because we're going to have other things after we go. Those are the rules. So we're going to put these into practice. Okay? So here are 5 compounds. They are all binary. They are all ionic. So rule number 1 is already checked. So we just need to go to rule 2 and 3, and we need to name these. Okay, so I'm going to give you guys a few minutes to work through these, and then I'm going to come back and we're going to answer these. So, and I want to say that this one, BAI, that's BAI, oops, BAI2. Okay, so I'm going to give you guys a few minutes, and then we're going to... So let's name these compounds. K2S, what is the name of it? And potassium sulfide. RBAT, what is that? Rubidium acetate. BAI.
All the same word.
Barium iodide. K2O. Potassium oxide. And SRSE. Strontium selenide. Okay? Are there any questions on how to do that? Now we're going to work backwards. I'm going to give you the name. You've got to give me the formula. So that is the hardest part of this. Yes?
How do you know, like, how would you know if, like, there's two or...
We're going to talk about that.
Okay.
Okay. Everybody good with this before I switch the page?
C.
All right, we are going to write the formulas. These are all ionic compounds, which means that they are all ions now. So the very first thing you need to do, once you've identified that it's an binary ionic compound, the first thing you need to do is to identify the ion charge. Aluminum, Al. What is the charge on aluminum? +3. What is the charge on fluorine? F -1. Periodic table, written at the top. Oh, not set in stone.
Oh, okay, I got it.
Okay, so that's the very first step. Once you've identified that, you have to look and we have to see, we have to make the overall charge equal 0. So if I'm looking at it right now, I have a 3 plus 3, and I'm adding a -1. Does it overall equal 0? No. So right now, when I add those together, it equals +2. I need them to equal 0. So how can I make this equal 0? I cannot half anything. Add 2 more F's. Okay, so if we add 2 more F's, so we can take the -1 and we can multiply it by what to get to 3? So we're going to multiply it by 3. We're going to multiply it by 3. 3 times -1 is what? A -3. What do I have to multiply +3 by to get it to +3? 1. Those multipliers are our subscripts. So the formula for this would be Al, 1 is understood, F, 3. You don't have to if you can do that in your head and know what's going on, then. If I know that I have a charge of 3 and a charge of a -1, I know that I need 3 more F's, or 3 F's to offset that positive 3. Okay? Sodium oxide. What is the charge of sodium? So, +1. What's the charge of oxygen? -2. Do those equal 0? No. So how many sodiums do I need? What does the ratio of this have to be so that it equals 0? 2 and 1. So the formula would be Na2O.
Are we going to be able to use our color?
I'm going to change magnesium sulfide. I'm going to change it to... Oh, no, let's go ahead and do magnesium sulfide. Mg, what's Mg's charge? +2. What's sulfur's charge? -2. Does that equal 0? Yes. So I do not need any subscripts. So the formula is... I'm going to change boron nitride to boron sulfide. Boron sulfide. Russell,
Yes, ma'am.
what's the charge on boron?
Oh, thank you.
+3. What is the charge on sulfur? -2. What is the common factor? What's the next multiplier to get those to an even number, to the same number? So it's 6. So this needs to be +6 and this needs to be -6. So we need to multiply B by 2 and we need to multiply S by 3. So my formula is? Okay, so now I'm going to show you something. I would pay very close attention. This number here, my subscript to B, matches the absolute value of the charge on S.
Whoa, that's a game changer.
The subscript on S matches the absolute value of the... So, let's do this. Let's do magnesium. So I'm going to show you. Magnesium chloride. What's the charge on magnesium? +2. What's the charge on chlorine? -1. So what you're going to do, if you don't like doing the math, is you're going to take the absolute value of the charge on chlorine and you're going to drop it and give that subscript to magnesium, Mg1. Next, you're going to take the absolute value of the charge on magnesium, take it and cross it and give it as a subscript to chlorine.
This just got a whole lot easier.
Cl2.
Thank you.
Now, when you're doing this, you might come up with, say, if we went to magnesium, you would do this. And you would come up with Mg2S2. And I'm going to count you wrong. We need to do what? What is the difference between this and this?
That's double.
Okay, so this one is simplified. So you need to simplify. So if you're doing the cross and drop method, you need to simplify.
So do we have to do the dot configuration?
No. If it helps you to do the dot thing, then yeah, you can do it. Simplify. Can 2 and 2 go down? That's the same number, right? So if I divide 2 by 2, what would that be? So we're going to get the greatest common factor All right? Any questions on that? This is the second part of your homework.
How don't you get like what are they called? Like the -2s?
The charges?
Yes.
Periodic table? You don't have them on there. So this is, if you go up to mine and look, this is +1, +2, +3, -3, -2, -1.
It's plus or minus 4.
And plus or minus 4 in between. All right, any questions over that?
What do you do for the plus or minus 4?
If you're doing your homework tonight, you're going to treat carbon. Do you have this on your homework tonight? You're going to treat carbon as a non-metal. So carbon's going to take the -4. All right, so your homework is binary, 1 through 20.